This program is made possible by a grant from the National Science Foundation, a co-production by Mississippi Public Broadcasting and the University of Southern Mississippi Gulf Coast Research Laboratory. April 20th, 2010, 41 miles offshore in the Gulf of Mexico, BP's Deepwater Horizon drilling unit exploded after high-pressure methane gas engulfed the rig and exploded. 11 people would lose their lives that night. For nearly 3 months, oil gushed into the Gulf of Mexico. Marine life, tourism, and petroleum operations will never be the same in the Gulf region. Now there are questions that have scientists focusing on trying to shed light on the unknown long-term effects on the Gulf. This is the Science of the Spill.
Hello and welcome to the Science of the Spill. I'm Erin Pickens.
And I'm Dr. Bob Thomas, Director of the Center for Environmental Communication at Loyola University.
The Science of the Spill is produced by the University of Southern Mississippi Gulf Coast Research Laboratory and Mississippi Public Broadcasting to inform the public with scientifically proven facts concerning the BP Deepwater Horizon oil spill. And Dr. Thomas, I think we can all agree that there are many myths and some information out there not based on scientific data about the effects of the spill.
That's right, Erin. We're going to bring together scientists that are studying this disaster for informative discussions to give the facts about issues related to the Deepwater Horizon oil spill.
Now, we also want to let you know that you can find more on our companion website, spillscience.com. There you can find in-depth information about topics related to the spill, as well as video discussions from scientists studying the effects of the spill on the Gulf of Mexico. You may also want to join the discussion on our blog section of the site, where you can engage in discussions with scientists studying the impacts of the Deepwater Horizon oil spill. Again, that's spillscience.com. Well, Louisiana has suffered a loss of its coastal wetlands at an alarming rate for many years. Has the oil spill had any impact on this problem? We visited with scientists and traveled to an area in Louisiana directly impacted by the oil, Bay Jimmy and Barataria Bay, for a first-hand look at this issue.
I think a lot of people in Mississippi and Louisiana and this part of the Gulf Coast are very interested in the natural progression of their coastline and the fact that we're losing a lot of coastal land every day. A lot of people are worried that by introducing oil at high concentrations into these ecosystems, that it will inhibit the natural processes that trap sediment and help counterbalance the loss of these coastal environments. So our research will hopefully help determine whether geomorphologic changes, that's a fancy word for changes in the rate at which we gain or lose coastline, that will hopefully help us determine whether or not changes in these processes can be linked to the oil spill.
So here we are out in Bay Jimmy, which is on the northern part of Barataria Bay. And a lot of oil accumulated out here in Bay Jimmy. It came up through the passes. There are some passes that are due south, passes being the term down here for tidal inlets. The oil came through the passes and probably got washed ashore on the edge of these marshes under the influence of southerly winds. Over there you can see where the oil is and has been. Some of the darker spots over there are most likely still oil. You can see that the oil stayed in the front, let's say 5 to 10 yards of the marsh. This is something that seems to have been something of a widespread pattern. We've often talked about marshes as good traps and good filters, and this is probably the best example I've seen of it, is that the marsh grass has trapped much of the oil in the front 5 to 10 yards. So I think that while this spill was certainly a nightmare and a disaster, it has to be put in the context of a coast that is unfortunately in a state of degradation. So what we've got here is a bunch of plant stems and plant roots and old plant material, and this was most likely all marsh, some years ago that has sunk into the sea. So this is part of the story. Is South Louisiana is right here in this anchor. If you take the amount of shoreline that was oiled and you multiply it by the length of the width that was actually oiled, you multiply several hundred miles by something that's maybe 10 yards, you only get maybe on the order of 10 square miles or less of coastline that was impacted, which is incidentally less than the amount of coastline that we lose in an average year. We lose somewhere on the order of 25 square miles of coastline in an average year, and in a bad year, much more than that. In the month surrounding Katrina and Rita, the coast lost somewhere close to 250, maybe a little less than 250 square miles worth of land. One thing that you can see is that the oil did lead to some mortality of the marsh plants. You can see what appear to be some dead marsh plants over there. The brown marsh is most likely dead. You can also see in the middle over there, you can see some new shoots coming up. And those are most likely shoots that have come up since the oiling event. So it's most likely some regrowth after the marsh, after the oiling event. The basic story, I think, of what's going on is that the plant roots didn't die. One of the biggest concerns people had when this oil was when the spill was breaking, was would it kill the roots? And people asked myself and people asked other people, will everything die off? And a lot of people said it depends on what happens to the roots. If the roots die off, we could lose the marsh, and by extension, if the roots don't die off, things can regrow.
I think if we had proper restoration efforts in place decades ago, we would have had complete barrier islands like the Chandler Islands. We would have had complete marshes in the Biloxi marshes. And it's just the physical nature of things. You have more avenues for this oil to enter. So if we had complete marshes in the Biloxi marshes, yes, we still would have gotten damage, but so much of the interior marsh, which is very important for juvenile organisms to spawn, would still be intact. We probably would not have seen oil getting as far in as Lake Pontchartrain. It's just a matter of physics. If you had more physical boundaries between the oil and the interior marshes, we would have had less problems. Now let me also say, though, that we need natural barriers. If you're throwing artificial barriers up there that will not be permanent, that are not held in place by plants and root systems, it's a waste of time. You need to support the natural restoration of the marshes and of the barrier islands.
It was very interesting to examine the added ingredient of the oil spill on longer lasting issue of coastal wetland loss in Louisiana. Let's turn to Dr. Bob Thomas for a discussion on this issue with our in-studio panelists. Bob.
Thank you, Erin. Our panelists today are Dr. Mark Peterson, who is a professor of coastal studies at the Gulf Coast Research Lab in Ocean Springs, and Carrie St. Pé, who's the executive director of the Barataria-Terrebonne National Estuary Program in Thibodaux, Louisiana. Mark, tell us something about your research background.
My research deals with fish ecology mainly as it relates to salt marsh and coastal habitat and losses or impacts of those habitat and how it impacts fishes and crabs and shrimp and things like that.
And Carrie, your background?
I spent my years after college in working for the state of Louisiana in the Division of Water Pollution Control, and for the past 13 years I've been director of the National Estuary Program.
Well, Dr. Alec Holker of the Louisiana University Marine Consortium pointed out that that all of the coastal wetlands that have been impacted by the oil spill thus far amounts to less than we lose in coastal Louisiana in a given year. Give us a background, Carrie, if you can, about why this historical loss of Louisiana coastal wetlands has occurred.
Well, in southeast Louisiana is a product of the Mississippi River. The Mississippi River drains 2/3 of the United States, and every year after the spring floods, after the snow melt, we had this enormous amount of sediment coming down here with the water. And it would flood its banks, depositing new silt on the sinking coast. The coast has been sinking for 10,000 years. It's just that it was offset, the sinking, with new layers of sediment. The river changed course about 8 times over geologic time, depositing new deltas and building land. In the last 75 years, we've destroyed that sequence of events that built the land. We've leveed off the Mississippi River. And more importantly, perhaps, we've built locks and dams in the upper part of the watershed, so we don't even have the early amounts of sediment that the river once carried. So even though we have the levees down here, which keeping from flooding, we probably wouldn't have enough sediments to offset the subsidence.
Well, Mark, how about Mississippi and other coastal states? Are they losing the same thing?
Well, in Mississippi, it's luckily we're very unique in that we don't have nearly the problem they do in Louisiana. But we do have an area in the eastern part of our state on the Alabama state line called Grand Bay. The part in Mississippi is a National Estuarine Research Reserve, and there was a stream that flowed into there thousands of years ago called the Escatawpa River. It was stream captured. It was sucked into, if you will, the Pascagoula River. And so sediment, just like in Louisiana, is no longer flowing out to accrete the wetlands. And we also have a very strong southeastern wind pattern that's eroding some of the small barrier islands there and some of the salt marshes there. But pretty much in the rest of the state, it's not bad at all.
So it's more coastal barrier islands than it is coastal wetlands along that part of the coast.
Yeah, and we have some small barrier islands, but you can clearly see some erosion on the salt marsh from that southeastern wind, but it's not being replenished, as Kerry talked about. But it's a much smaller scale problem than we have in Louisiana.
Well, Kerry, you know, we know that this is an enormous problem. Why is it important to the citizens of Mississippi and Louisiana that these coastal wetlands are disappearing the way they are?
We have an enormous wetland loss issue, and the wetlands are a part of our culture. Aside from that, the wetlands produce an enormous amount of fisheries for the nation, and they house all the oil pipelines which are protected with the marshes and the oil infrastructure. Everything is protected with the marsh and ridge infrastructure. Our communities are very vulnerable now with storm surges. They could cause an increase in insurance rates. We no longer have the ridges and marshes to offset, to buffer that storm surge. So at the very least, they should be concerned for what the estuary produces, both renewable natural resources and non-renewable natural resources, as well as insurance rates that affect the whole country.
Mm-hmm. And not to mention the cultural impacts that we have along our coast. We're so tightly tied to these wetlands.